Okay, we're in section 5.4 now, page 1 of the notes, and we're going to be using system of equations now to do some problem solving, some word problems or application problems. So let's review some of the techniques that we developed in Math 60, and these are slightly different than how the book presented, so again you can choose which method makes the more sense and works consistently for you. What we did in Math 60 was we made a habit of reading the problem, and if you can, read it out loud. That just helps to unlock some of the things. Then we pause and take a deep breath in and out, kind of calm ourselves down, refocus, and before we jump in to try to solve it, we read it again. Sometimes it helps clear things up, makes it seem not so scary, not so wordy the second time through. I would encourage you that if there's anything in the problem that causes you to imagine a picture, go ahead and draw that on paper. And of course, after you've read it twice, you're going to start to highlight the key information that's given. Before we do any sort of setup or solving, though, we want to make sure we have our goal in mind. What is it that they're actually asking for? And put somewhere on your paper the final answer that you're aiming for, so you don't stop until you get that actual answer. Okay. Oftentimes I'll put an exclamation point on my paper or a line for the answer and a description near the bottom or near where I think I'm going to land so that I remind myself exactly what I'm going for. And then we're going to work on the setup. And in this case, while we're in the section called Solving Using Systems of Equations, we can expect the setup to match the section that you're in. So we can expect the setup to match the section that you're in. In this case, it's going to be two equations with two unknowns, whether that be x or y, or if we pick letters that relate closer to what the problem is. So two equations, two unknowns. Then of course, once we get to that point, we're going to use what we know to solve the system. In this case, it's a system, so we have three choices. We can either do it by graphing, which is what we did in 5.1, or we can do it by substitution, which is what we did in 5.2, or the addition method, which is what we did in 5.3. So we have three choices, totally your choice which one seems to either fit the situation or you like and feel most comfortable with. And then of course with any problem we should do some sort of a check. And in this case, when we look back on the problem, we want to check our answers in the original story. And that's just a double way of checking both our algebra work but also the setup. When you're translating from the words to an equation, and then you solve those equations and get an answer. If you take that answer and put them just back in the original equation, you might convince yourself that you did the algebra right, but to convince yourself that you did the setup right, you need to check that answer back in the original story. So that's what I mean by that. Okay, let's look at page 326, number 16. It's a little dark on the notes, so you may want to go to the book to reference this. Also, I will fix this in future videos and notes, but I ended up copying this from the book, the teacher manual. So you'll see the answers in blue here. Try to ignore those and just work on the problem, but it's one of those things. Okay, so let's read it for the first time. A rectangular lot whose perimeter is 1,600 feet is fenced along three sides. An expensive fencing along the lot's length costs $20 per foot. An inexpensive fencing along the two side widths costs only $5 per foot. Total cost of the fencing along the three sides comes to $13,000. What are the lot's dimensions? Okay, all we've done here is just read it out loud. We're not in any space or shape ready to jump in and just solve this. Okay, so we're going to take a deep cleansing breath, calm ourselves down, read it again, keeping in mind that there might be something we can draw to help us understand or something we can highlight to help us understand. So as we read it again, a rectangular lot, okay, that seems important, whose perimeter is 1,600 feet, perimeter is 1,600 feet, is fenced along three sides. Expensive fencing along the lot's length costs $20 per foot, and inexpensive fencing along the two side widths costs only $5 per foot. Total cost of the fencing comes to $13,000, the 3 sides. What are the lot's dimensions? Okay, so I've just kind of highlighted some things as I went here, and let's look to see what we can do. There is something we can draw here. We can draw the rectangular lot. So I'm going to go ahead and do that and draw a rectangle, and we've highlighted some things in here, and we've got a width and a length, and they're only going to do the 3 sides of fencing, so there's no fencing up here. Okay. And then we've got, then we can highlight some things. And let's look at our goal. The actual question that they're asking here is, what are the lot's dimensions? Okay, so we drew. Now let's look at what our goal is. What are the lot's dimensions? So the goal is to come up with the lot's dimensions, which means we want 2 answers here. We want what the length is equal to and what the width is equal to. It looks like we're dealing in feet, so I'm just going to remind myself I need to label those answers. The length is going to be a certain number of feet, the width is going to be a certain number of feet. So that's my goal. I'm going to go ahead and highlight it for myself. I don't stop until I get to those 2 answers. Okay? And we talked about in Math 60 that sometimes you have to bring your own formula, bring some information to the problem. In this case, while they tell us how to kind of draw the picture, they tell us we've got 3 sides, they tell us the total cost, they tell us the cost per foot of both types of fencing, width and length. They just mention the fact that it's a perimeter. So we're going to go ahead and bring our own formula, BYOF. Bring your own formula. In this case, for perimeter, the perimeter is going to be adding up all the sides. So when we do that, perimeter is equal to 2 of the widths plus 2 of the lengths. And in this case, they tell us that perimeter is equal to 1,600 feet. And now we look at the setup. We can expect it to match the section that you're in, right? So part of the setup is to look to see if there's any bring your own formula situations, which we did. And now we're going to look for 2 kind of sentences, 2 descriptions that we can translate into 2 separate sentences. Some of these problems, though, as we go through 5.4, might be very, very similar feeling to what we did in the problem solving in Math 60. And they are very similar. The difference being now we're going to go ahead and try to set up 2 separate equations. In Math 60, all we had the skills to do was set up 1 single equation. So these will feel a little bit different, and as we go along, we'll talk more about, how do you know when to do 2, when to do 1. Okay? In this case, because we're in the section about systems, you can expect to set up 2. So for now, just rest in that. We can set up 2 equations. So the first one we're going to set up is one about our perimeter, and I'll abbreviate that, perim, here. So our perimeter, what we know is that 1,600 feet is the total perimeter, and we know we find perimeter by doing 2W plus 2L. So I'm going to go ahead and write that out. 2 of the widths plus 2 of the lengths is equal to 1,600. Notice that we do use the side that doesn't have fencing because we're just talking about the perimeter of the lot itself. So this is the formula for perimeter of the lot. However, the other information that we have has to do with the total cost. And the total cost, they tell us, is of the 3 sides added together. So we have 2 widths at $5 a foot, so W times 5 plus W times 5 plus the length at $20 per foot, and that's going to equal $13,000. So there's our setup. There's our 2 equations. Okay. And then we're going to solve this system. Now, looking at it, I'm not really sure which method I want to use yet, so I'm going to go ahead and simplify this second equation before I decide how I'm going to use it. So I'm going to go ahead and rewrite this second one to be 5W plus 5W is going to be 10W plus 20L equals 13,000. and then bringing the first one down. Here's your 2W plus 2L is equal to 1600. For me, this one looks like it wouldn't take much effort to be able to use the addition method. So I'm going to go ahead and multiply either the top or the bottom equation by something that will cause one of the variables to have equal but opposite signed coefficients. Okay, so I could multiply the bottom equation every term by -5, which would give me a 10 on the top and a -10 on the bottom. Or I could multiply everything on the bottom by a -10, which would give me the +20 next to the L on the top and the -20 next to the L on the bottom. I think I'll stick with the smaller numbers, and so I'll multiply the bottom by the -5. So now what our system looks like, and I'm going to kind of pull, let's see, do I want to go to the side or over? I think I'll go ahead and rewrite the system down here and bring this 10W plus 20L equals 13,000 again. Just bring that one down here, but then bring my second one after I multiply here. -10W, the -5 is going to get multiplied by all three, plus 2L is -10L. And then 1600 times -5 is going to be -8,000. The key there would be to multiply all those pieces by that -5. Okay, and then I'm going to go ahead and use the addition method and add these together. And 10W minus 10W, those cancel. That was the point. You want the W's to go away, or at least one of the variables to go away. 20L minus 10L is 10L. 13,000 minus 8,000 is 5,000. And then it wouldn't take long to figure out that the length is 5,000 divided by 10, or just 500. Okay, so we found our length, 500 feet. And then we're going to be able to use back substitution to come up with the width. So you could pick any of the formulas. It's best to go back as early as possible. I'm really sure about my perimeter formula, so I'll go ahead and use that. So I'm going to bring down my perimeter formula and plug in my 500 value for my L, and then solve for W. So 2W plus 2 times our L equals 1600. So I'm putting that 500 in here. And now solve for W. 2W plus 1,000 equals 16,000, or 1,600, sorry. 2W minus the 1,000 on both sides is equal to 600. Divide by 2. W is equal to 300. So now we have an answer of 300 feet. I just realized I didn't put the T on there. Sorry about that. Okay, so 300 feet there. And then we've solved it. I have found my two goals, 500 feet by 300 feet, but I want to check it in the original story as I look back. So the rectangular lot, perimeter 1,600 feet, is fenced along 3 sides. So I would take the length and the 2 widths. So the length is $20 per foot. If I do 20 times 500, that's $10,000. And then if I do along the 2 widths, $5 per foot. So if I did width 300 at $5, that's $1,500. Another width 300 at $5, that's another $1,500. So we had 10,000 plus 1,500 plus 1,500. That is the 13,000 that they said the total cost would come to. So I'm doing the check in my head just simply because I ran out of paper space here. You do a check that makes sense to you and helps you either on paper or mentally, or talk it through with somebody. But there's our answer, 500 feet by 300 feet.